Okay, let's continue this problem by actually evaluating the integral. So I'm going to simplify the line above by basically figuring out what this would be first and then this would be, and just rewriting things after they've been simplified. So the integral from 0 to 4 times pi, that's just recopying the first two things. And then 2y minus 0, when I square it, is the same as 2y squared, the whole thing squared. So 2y, the whole thing squared. So that's 4 times y squared. So 4 times y squared. And then minus, and the same for the other part. This would be y squared divided by 2 minus 0. So that's the same as y squared divided by 2. And then I square the whole thing. So that becomes y to the 4th divided by 4. Y to the 4th divided by 4. And then still dy. So all I did in this step was simplify this by making that 4y squared. And then I simplified this by making that y to the 4th divided by 4. Okay, so now all I'm going to do in the next step is move the pi constant to the outside. So pi times 0 to 4. So I just took this and moved it to the outside. And then I have 4y squared minus y to the 4th divided by 4 dy. All right, well then that's pi times the antiderivative of 4y squared is 4 times y to the 3rd divided by 3. So 4 times y to the 3rd divided by 3. So all I did was rewrite the constant. And then y squared, when I integrate y squared, I get y to the 3rd. Remember, I take the exponent and add 1. So that's a 3. But then I have to divide it by whatever I got, so that's 3. And then minus 1/4 times y to the 5th divided by 5. So I moved this 1/4 and wrote it out front. And then integrating y to the 4th is 4 plus 1 makes 5, and then I divide it by 5. Okay, so then I need to evaluate that from 0 to 4. So for the fundamental theorem of calculus, I put in the 4 first. So I have 4/3 times 4 cubed. So this 4 went right there, and I wrote the 4/3 as a fraction out front. And then minus from the problem, 1/4 times 4 to the 5th. So 4 to the 5th divided by 5. So I take this 4 and put it there, and then still dividing by 5. And then all of that is minus from the fundamental theorem of calculus. I'm going to put in a 0. So when I put in 0 into there, I'm going to get 0 cubed, which is 0. So the whole thing will just be 0. And then minus, that minus comes from this minus. I'm going to put in 0 in for here. So I get 0 to the 5th, which is still 0. So that whole thing is going to be 0. And then end. So I'm left with pi times 4/3 times 4 cubed is 64 minus, and then 1/4. If I simplify this part, the 1/4 and then the 1/5, that's 1/20. So I'm going to write 1/20. And then times 4 to the 5th. I didn't know what that one was, so I had to type that in my calculator. 4 to the 5th is 1024. 1024 is 4 to the 5th. And then it's just a matter of simplifying that. So 4 times 64, and divide that by 3, and I get 256 divided by 3. 256 divided by 3. And then 1024 divided by 20 is the same as 256 divided by 5. Then when I simplify that, I get pi times, I have to find a common denominator. I get 512 divided by 15. And that's my final answer. Sometimes we usually put that pi symbol constant second, so it's probably more familiar to write it as 512 divided by 15 times pi. Okay, so that's how I would evaluate that integral. I hope